So I'd like to welcome you for today's webinar about Creo Parametric mechanism design. My name is Urs Simler. I will show you a little bit about this tool in Creo Parametric called Mechanism Design Extension. First, I'd like to introduce myself, the company I'm working for, and then I'd like to talk a little bit about the capabilities of mechanism design, and for sure we are doing quite a lot of demonstrations. I will use here a lunette. This is for a turning process, an additional device, and I will also show you a nice example. I got it from GrabCAD. This is a radial engine. If you have any question, please use the question panel in the GoTo webinar application, and at the end of the webinar we'll have time to answer your questions. So first about me, my name is Urs Simler. My name states for simulation expert. I'm working for a company called GIA Informatik. I've been with the company for 4 years, and yes, before I worked 20 years for PTC as a pre-sales and consulting guy. Not in the call is our salesperson, Daniel Losley. If you have any question about sales topics, you can contact him under these coordinates here. Okay, and I'm also an owner of a YouTube channel. Feel free to subscribe for this channel. You'll find there a lot of webinar recordings, tips and tricks, and animation from components in the simulation environment. Okay, GIA Informatik is a company with about 140 people located in the middle of Switzerland. We are a PTC reseller. We have an own IT services, and we are also a reseller of SAP solutions in the CAD/CAM environment. Our main partner is PTC, and of course we also support additional application in the CAD PLM environment. So we're doing training consulting in the PTC Creo Parametric environment with PTC Creo Elements Direct and all the other tools from PTC. As a topology optimization solution, we use ProTop from another Slovenian company called CAESS. We are also support you with AutoClear, electrical clearance and creepage analysis from Elaborate. We sell solution from an Austrian company called TechSoft and from a German company called Software Factory. We are monitoring some customer, PDM customer systems, and we have an own training center in Oftringen. But today's topic is Creo Parametric mechanism. I think this is a quite old module. I guess it was invented in about 1998, last century, but I think there are quite interesting capabilities in this tool. Mechanism is divided in two let's say options. The mechanism design extension is included in every Creo Parametric license, and this one, the additional option, dynamics option, this is an additional module. You have to pay additional license fee for it. So mechanism design extension is taking care about kinematics, and the dynamics option is taking care about the dynamics. So dynamics means forces, force and the body motion is captured by it, so you can see the forces and all that kind of stuff. And with mechanism you just see, let's say, the animation or movement behavior of it. So that means with, let's say, the standard license we are going to demonstrate today takes care about clashes, about the velocity, about collision detection, about mechanism envelopes and that kind of stuff. And let's say the RedMark tool, it's more an advanced tool where we can see the forces and we can control, let's say, the acceleration behavior of our component. I will not show mechanism dynamics option today. Okay, here we see also the capabilities of the extension in green here, and of course the additional capabilities of mechanism dynamics option. Okay, so in detail, what can we do with a mechanism design extension? We can check, does our mechanism work? Are there any interference while I'm moving my component? What is maybe the speed of a certain point? What's the acceleration of a certain point? I can capture motion envelopes and all that kind of stuff. So I can see the kinematic behavior of my mechanism here. And I think it's quite easy to use because it's integrated in PTC Creo Parametric. It's quite easy to use because you're in assembly mode and you just assemble your components with so-called connections. Instead of, let's say, using references, you're just creating connections, and with the help of the connections you can set some limits on that connections. You can move your component, you can drag your component, you can save your, let's say, exploded states, you can bring it to the drawings, you can create some motion envelopes, trace curves, and of course you can see the movement, be it the kinematic behavior of a component. You can create some movie to explain, let's say, the functionality of your mechanism. And all starts, let's say, with the different type of joints you're using during the assembly process of your components. And here it's quite important that you know all that capabilities of joint types, and I think it's also quite important that you know that you can set here some limits. It's also possible to create here some regeneration positions here. And I think it's also interesting you can capture these positions and bring the positions to the drawings. In addition to, let's say, these joints like pin, slider, cylinder, planar, bolt, bearing, and so on, you will have other connection types like gears, cams, 3D contacts, and belts. And with that kind of connection, we can, let's say, extend the capabilities of joining our components. And here there is a quite, let's say, interesting capability within mechanism design. We call it the drag capabilities. In the assembly mode, you see here a symbol like that here, and with that symbol in that menu, you can save here some snapshots, and at the end of the day you can save the snapshots as exploded states, and these exploded states can be brought to the drawing. I will show that later on. For the behavior, for the moving behavior, you can define different servo motors with tables, with ramp functions or user-defined. And then let's say your component will hopefully move as you defined it. So later on we'll see that also in the live demonstration. An additional capability within mechanism design extension is to generate envelopes, shapes, and all that kind of stuff. That means we can do some CAM synthesis. So we are defining here maybe a movement behavior, maybe here on that slider joint here. And while we are moving that component with that behavior, we are turning our cam here one time, and we can create a curve here, and we can use later on that curve with a cam connection, and we, let's say, move our component here, and in the end we are getting the behavior, the movement behavior on let's say the end of our mechanism. This is quite an interesting capability. We have two different type of analysis we can perform with mechanism design extension. This is a position analysis and the kinematic analysis. So the kinematic analysis will also give you information about accelerations and velocity. And let's say the position analysis is just showing us the movement of our component. And let's say our drivers in a position analysis can also be like that here, so they don't have to be in that situation. Let's say C2, they can be also, let's say, oh, how is it called? I don't know in English. But with the kinematic behavior, you really must make sure here that the kinematic behavior is smooth. Okay. We'll see that also later on in the demonstration. Of course, we can set up different of measure types in order to, let's say, see the position, the distances between those parts, and we can set up different evaluation methods like average or integral or what else. I was talking about, let's say, the placeholders, trace curves, and motion envelopes. Here we see a typical motion envelope of an engine. Okay, I will also show it later on during the demonstration. Okay, when you analyzed the movement behavior of your components, you can also use that movement in different PTC tools like Creo Illustrate or Creo View, and therefore you have to export the results as a FRA file, and this FRA file can be taken into Illustrate or Creo View in order to see the analyzed movement behavior of mechanism design or mechanism dynamics option. And of course, the movies you are creating can also be rendered in order to get nice films. So today's component will be a lunette. I don't know the word in English, but this is for the machining, turning process you quite often need here in the middle. You need a support in order to have here, let's say, no displacements on your machined component. And here let's say this component must support different diameters, and therefore we must, let's say, check the behavior of this component. Later on, I will show an additional example. I grabbed that from a community called GrabCAD. Here under this link you'll find, let's say, a very, very detailed radial engine from a user called Matt, and if you're a member of GrabCAD you also can download it. So the movement, the mechanism is, everything is modeled in this data, and you really will be astonished what kind of work is behind that mechanism. But let's start here with Lunette. Therefore, I will switch to Creo Parametric. Creo Parametric 6.04, and this behavior or this mechanism can also be analyzed, I would say, in Creo Parametric 1 or even in Pro Engineer Wildfire, I don't know what. So let's start with it, and let's open a component here. So I assembled here a housing by default in this assembly, and in addition to that I'm bringing in additional components. I'm taking here this middle part, I'm opening that one, and by holding down Control and Alt key I can move my component in or relative to my assembly. And in that area up here, instead of using, let's say, references like coordinate systems and mate it, I will use here the capability to connect the components with joints. And I want to create here a slider joint, and I want to have a movement of my middle part here in that direction. Therefore, I'm also showing here, let's say, the datum axis, and I'm redefining here again, and I'm using here a slider joint. I'm selecting here the axis itself, and I can see here the behavior like that, and I can see here the rotation behavior. For, let's say, a successful placement, Creo Parametric wants me to select additional references in order to prevent that rotation. I'm doing that with that reference and that reference. My part's changing the color, or my component is changing the color, and it states the definition is complete. Of course, maybe in that area up here, I can see I'm getting here some interferences. Therefore, I want to stop here the movement of that component, and I'm defining here, let's say, some references to get, let's say, the axis movement here. And I have also the capabilities to bring in here some additional limits. I'm setting the limit at 60 millimeters. Therefore, let's say the movement, the further movement to the left isn't possible anymore. I just can move it in that direction because I didn't, let's say, stop here, or I didn't set the limit there. An additional capability is I can also bring in here a specific position, and I can, let's say, bring this value here as a regeneration value, and I can say, okay, always when I'm regenerating my part, this position has to be taken into account. That means, okay, I can move that guy here until 60 millimeters, here until the end, and if I push here regenerate, I will see a position of 100 millimeters from here to here. Okay. And in that area, we are getting, let's say, a specific symbol, this guy here. And this symbol states with the point in the middle that this component is connected with a joint to another component. Okay, let's bring in an additional component here. Let's take this Hebel. Okay, the Hebel has to be placed up there. And in that area here, I wanna use a pin joint. Okay, I'm switching here to pin joint. I'm selecting here some references. Okay, and in order to get a reference in the housing, I'm selecting those two surfaces. This guy here can spin around, but I wanna, let's say, also set some limits. Therefore, I'm going for the rotational axis. And by selecting two references, I'm getting an angle. I'm switching the angle direction to that direction, and I can see, okay, this guy here can be moved around maximum limit 176, and maybe to the other direction here. When I'm moving that guy, I think he cannot go further than about, let's say, this limit here. So that means I'm setting here on the rotational axis maybe a limit of, the minimum limit of 120 millimeters. Okay, and now I can see I can move that guy here, and in, let's say, the application mechanism itself, I can bring here some additional connections like cams, 3D contact belts, and gears. And in that area, we can also see the additional capabilities of mechanism and dynamics options. So if you do not have that license, these icons here will be grayed out. And for the demonstration, I will not use that icon. So I'm just using a mechanism and design functionality. As I'm doing right now, I'm building a cam. And in order just to be able to select surfaces, I'm switching the filter to surface, and I say, okay, I want to connect this guy or the surfaces here by holding down the control key, okay, to the next cam. And I'm selecting here, let's say, the cylindrical surfaces. Okay. And because the properties of liftoff are not enabled here, the component here or the cam will connect, of course, and I can move my component as far as I like. Okay. And of course here we see, okay, it stops because of this limitation. And of course, if I hit here the Control G or regenerate button, it will move to a position of 100 millimeter. I'm going back for assembly mode, and in the assembly mode I'm bringing in the next component, this subassembly, and it should be connected here with the help of a pin joint. Okay, I'm setting that pin, and this time I'm a lazy guy. I do not set any limitations. That means, okay, this can spin around like hell. Going back here again, maybe for mechanism, in order to connect this cam here. Using again maybe only the surfaces, this, control, this. Middle mouse button should be connected to this cylindrical surface. And because liftoff is not enabled, it connects, and then can see the behavior here. And here we can see, okay, we're getting an interference, and I can also use, let's say, this cam connection to prevent this interference. I'm using cam connection. I select those surfaces here, they should have a connection to those surfaces here. And in that case, I'm enabling the liftoff. Okay, that means this guy is not moving here to the, it's not connecting always. It doesn't allow me to, let's say, interfere. And I can see that behavior. Of course, I can see right now here if I'm, let's say, redefining this axis connection, then I can see, okay, the limit of that position. That means I can move until 178 millimeters. So that means for me the movement right now is possible between 60 and 178. Therefore, I'm bringing in here a additional servo motor, and the profile of this servo motor can be influenced by several functionalities. I'm using here right now a table driven motor with the help of 2 rows. I say, okay, at the time of 0, the position should be 60 millimeters, and at the time of 10 seconds, here the position should be 178 millimeters. I can check the behavior of that one. And of course, right now I have a linear behavior. I could bring in here monotonic behavior to have a very, very nice behavior, or I can use here right now a spline, and because I have 2 points, it will also be a straight line. Okay, so it's quite easy to set up this, let's say, motors. And let's maybe go back to assembly mode, because I need any additional components here. And in that case, I want to assemble here a single part called Schwenkerkolung O. This is the top component, and it should be connected here. And for this connection, I'm using here additional points. And I want to connect here in that area with a cylindrical joint, and in that area here, I want to connect that line here with that point there. So let's do it here. First, I want to create a cylindrical joint from that surface to that surface. So that means my component can be moved in that direction, and it can also move or turn around the axis here. But at the end, I want to, let's say, connect, or right now I will connect this line here with that point from the pin. Okay, and therefore I'm bringing in here a new set, and this set should be not a cylindrical connection or cylindrical joint, it should be a slot connection from that line to that point. And of course my component moves also in, let's say, this I call it Z direction, to a specific position. And of course, if I'm checking now the behavior of my component, and I can see right now, oh, it moves great. And of course here later on I will use then later on the inverse kinematic behavior to create this slot. In order to finish my component, I'm using the last part I'm going to assemble. I'm assembling it here with the same connections as before. First cylinder joint from that to that, and oops, and here I'd like to use, I can do that also the right mouse button here by adding a new set. Okay, and I will use here a slot connection, that guy here to that guy. Okay, good luck for me. Looks not that bad, and we see here the behavior. And here we have also the capability to drag our components. Normally I'm doing the dragging by holding down Control and Alt key. I'm just moving or picking my component and moving it. But here with that capabilities, we are getting an additional menu, and here under the constraint folder we can define exact constraint to see, let's say, a specific position. I mean, here I can drag my component and I call it, okay, I save that position by clicking on the taking snapshot icon. I can name it. Maybe this is off. And by moving right now, it's here, I will say, okay, there's an additional snapshot called on. Okay, and here, very, very interesting, I can set the specific motion axis constraint by clicking here on my slider joint axis. I can bring in here a specific value. Maybe I want to see 122 millimeters. Okay, pressing enter, and now I see 122 millimeters. I can save that one and I rename it as 122 millimeters. Enter button. I'm going back for my snapshot tab, and by clicking on that one I can see the off position, I can see the on position, I can see the 122 millimeter position. And I can save these positions with that icon as a exploded state. So as soon as I see these icons, I'm getting the chance to save that position on a drawing. Therefore, I'm creating a new drawing. Drawing here, use default templates. Of course, I want to maybe use that guy here. Okay. And it's creating here a nice drawing. He wants me to bring in additional parameters. Yes, let's define some of them. Okay, and it's telling me an exploded state is not there. But right now I just want to create here additional views. I'm going here for general view. Okay, should be placed here. And I want to use here maybe the view from front. Okay, and I want to see here the states, the exploded state of on. And maybe here on the view display, oops, do you want to apply changes? One moment. Apply view states, view display. I want to see it shaded with edges. Okay, so I can see that state here, and in that area I want to see the exploded states of 122 millimeters. Apply, and here I want to see it also with shading with edges. So it's quite easy to bring in, let's say, different states to a drawing. And I would say this is nearly impossible if you'd like to do it with another technique. I think that it's a very, very important capability of mechanism and design extension. Let's go back to the assembly mode. Okay, and let's go here for the application mechanism itself. And yes, let's see maybe the distance. I want to check during the movement. I want to check, let's say, the distance of this component here to that component. And this can only be done when you create before in assembly mode a distance analysis feature, and this can be done here under, of course, analysis. I want to do here a distance measurement between two parts. I'm clicking on these two parts. I can see the actual distance, and by pressing this guy here, save, I can save this as a feature, and I say this is maybe distance from part 1 to part 2. Okay, and I'm getting in my model tree this analysis feature. This analysis feature can later be used for measuring the distance during the movement of my components. I'm going back for mechanism to create an analysis. As you remember, I created here a motor over 10 seconds. Therefore, I'm creating here a new analysis over 10 seconds. I can bring in here position or kinematic analysis with mechanism design extension. These three analyses, there you need an additional license from mechanism dynamics option. Let's do a kinematic analysis, kin 10 seconds. Because all the active motors will be taken into the analysis, I do not have to bring in an additional motor. I just say, okay, I wanna start the analysis here, right mouse button with the green flag, and we can see the motion behavior of my component. Of course, here under the measure type, I can bring in, or I can see, let's say, the actual measure of these two distances. I can see that maybe here in this graph here. And of course, when I'm, let's say, in that position, this distance here will be constant. Oops, I have to move that a little bit down. This is the area where this distance here is the closest one. And of course, if I'm maybe in that area, the distance here will be the closest. I guess this is that one. And of course, at the end of my analysis, these components are nearly touching each other here. Okay, so it's quite easy to, let's say, see the distance of two components. In addition to that, you can also define additional, sorry, that was the wrong icon, additional measures. As an example, you can see maybe the velocity, and as an example, I'm just selecting here a specific point. I call this measure V. Okay, and also the V can be shown here in a graph. This graph can be saved to Excel, all that kind of stuff. And when you want to see, let's say, the behavior of this velocity, you also have the capability to display, let's say, measures as an arrow. And here I want to see maybe the velocity arrow a little bit bigger. And if I start my movement, I can see here this arrow. And I can see here the velocity of that guy. Okay, it moves back. So it's quite easy to understand my mechanism and to see all the interesting measures on that one. Okay, I'm stopping that one here. In, let's say, the playback mode, you also have the capability to create motion envelopes with a specific level. I want to create a motion envelope as an example here of that guy and that guy here. Okay, I can see the preview. Okay, I can save that guy. And of course, if I'm going back for my assembly mode, then I can assemble this guy here. This is environment 2 to the default constraint. I'm getting here, let's say, a placeholder for the movement of these two cylinders. Okay, I'm stopping the assembling of that guy, and I'm going back for mechanism design itself. And in mechanism design, I want to create now here this this cam. Oh no, it's not a cam, this trace curve, and that can be done quite easily. I just need the movement behavior. I'm starting the analysis again because I didn't save it. And right now I can go here for analysis, and I want to create a trace curve. Okay, therefore I need here some points. Okay, and I say I want to create a trace curve on that paper part here of that point, and I want to use that movement behavior. I want to create here a 2D curve. I'm hitting the preview button and I can see this curve here. This is now saved in that component. The same can be done by using a trace curve here, paper part of that vertex with that kinematic behavior, and this will be saved there. So that means right now I'm opening that component. Okay, and here we see that additional group of trace 2D curve, and here we see the curve itself. I'm going to display it, and I want to go for that surface here. I want to create an extrusion. Okay, and the easiest way with an offset of 8 millimeters, minus 8 millimeters. I'm creating here the cam. I'm using additional arc from here to here, using an arc from here to here. Okay, and I want to create here a cut. Okay, this is going through all. Cut is done. I'm going back for my assembly, and I can see here, okay, this nice slot follower. I'm not doing the other one here, the other cut. I think this is the same behavior. So I'm going back for my mechanism itself, application mechanism. In that area here, mechanism, that area here, I'm starting the analysis again. Okay, and a nice product is also you can create here some movies in that area. We can also, let's say, see collision detection during, let's say, the movement. I don't want to do it right now. I just want to create here a movie itself. So by capturing here that one, I can create a movie called Shock. Okay, this is an MPEG, and now the movie Shock will be saved on in my working directory. Of course, you can also render this movie, and within 20 seconds this guy was created, this movie. And here, oops, I wanna open an Explorer, and here on the Lunette you see, okay, this is now the movie called Shock. Quite nice. Okay, this is also nice capability of Creo mechanism. Yes, and of course you can also create, let's say, quite complicated mechanism, as I stated before. You're going here for the next component here, that guy, this radial engine engineered by Matt on GrabCAD community. Let's have a look at this mechanism. It takes a little bit more than half an hour to create it. And we want to see how Matt assembled his mechanism. Therefore, I'm going here for that guy. So here we see a very, very detailed engine with all, let's say, the features here. He created also a version with a cut inside in order to get, let's say, better information, what's going on inside. And this guy, Matt, also created here a subassembly with all the internal behavior. In that area, I was already suppressing all, let's say, the springs which were assembled with so-called flexible components as flexible components. And here I'm just holding down now my Control and Alt key, and I'm turning here that propeller, and you see, okay, everything is moving. Maybe in that area, see we have here a cam connection. As soon as I'm moving, this part is moving over that cam connection, this will also start to move here. Let's turn again. This is really live on an old laptop. And I guess I didn't count it, but in this, let's say, assembly, there are at least 150 connections inside. We see here also some cam connection. We see additional connection. Let's go for this mechanism itself. This radial engine has, let's say, 10 cylinders, and therefore I really think 150 connections are inside. And of course there is already a kinematic analysis is defined. I can start that one, and here a little trick: if you have a very, very big assembly and you want to, let's say, run that one, it takes here quite a long time. So you can stop here the analysis, and by holding down the right mouse button, you see the settings, and you can let's say switch off the graphical display during run. That means right now if you start the analysis, it goes much quicker here. You cannot see the movement during the analysis, but you save, let's say, 60-80% of the time for, let's say, analyzing big models. And of course later on in the playback mode, you can see here the movement behavior. Okay, that area now we can start with that guy here. And everything is modeled, and of course you can see the accelerations, you can detect clashes, all that kind of stuff can be made with this mechanism, which is included in every license of Creo Parametric. Great, that brings me to the end of this analysis. Somebody stated here, sure, old laptop, smiley, smiley. Yes, it's an old laptop. It's 3.5-year-old. It's an old, now it's quite a good laptop, but it's an old P50 of Lenovo. And I would say today you have much better laptops here. Okay, then let's go back to the PowerPoint presentation. As I stated before, if you want to have that model, you can download it here. The link will be sent out to you. And additional information during, let's say, the lockdown, GIA is also performing some Power Online live workshop. If you're interested, We have live shops about this tool mechanism, about Creo Simulate, about freestyle and flexible modeling. Unfortunately, let's say this slide is in German, but if you're interested, we can also do a English workshop on that one. I will check, let's say, the question panel. Are there any questions so far? One moment, yes, there is one. When I press the mechanism button on the analysis tab, I get Creo error. The option mechanism design has not been acquired. Oh, that might be if you really have a very old version or license. This must be at least, I would say, 12-year-old. Then mechanism design was not included. And if you're maybe working with a license feature called Mechanica Foundation, then you also do not have this mechanism design extension. But let's say with a normal Creo Parametric license, which isn't older than 12 years, you should have access to mechanism design extension. If you have any problem, please send me a mail or call me directly. Then there is another question. Can you share the model inclusive the lunette? Yes, I will share it to the person who likes to have it. Of course, you just have to buy me a beer when we see us next time, but no problem. If somebody likes to have this model, please send me a mail and I can distribute it. I'm waiting for other questions. Yes, the beer is confirmed. Thank you. Next question. On the wind chill, is it creating any new object in the database? No, not at all. This is also a nice behavior because this is a really integrated core product. This is Creo Parametric, or it was Pro Engineer, it was Wildfire, what else? There is no additional file created by Creo Mechanism Design. Only when you write out maybe the movement behavior of your component. When I'm going here for my lunette again, and you go here maybe for the playback, then in that area, if you say, oh, okay, I want to create here the results, or I want to create the FRA file, then a new object will be created. But by default, everything is stored in the main assembly. And if you assemble that assembly somewhere else, let's say also this information, including drivers and what else, will be or can be used in let's say all the other assembly, in the main assemblies. So I'm checking again the question panel. I guess there are no more questions so far. No questions, all good? Yes, then I would say that brings me to the end of that webinar. I'd like to thank you for your time. I hope this webinar was interesting for you. As I stated at the beginning of the webinar, tomorrow you'll get the download link for presentation and recording. And yes, I'd like to thank you for your time. I'd like to thank for the beers I'm getting for my lunette. And I hope we'll soon see us soon. I hope live or somewhere else. And I wish you very, very good health. Stay safe and sound, and really I enjoyed it to present you this module. Take care. See you soon. Bye bye. Arrivederci. À bientôt. Au revoir. Auf Wiedersehen. Bis bald mal.